Hey everyone, and welcome back to another episode of our Lua series. Let me ask you something. What if I told you there's a single data structure in Lua that can act like an array, a dictionary, an object, and even a prototype for inheritance all at once? Sounds wild, right? Well, in this episode, we're unlocking the full power of tables in Lua, Lua's most flexible and game-changing feature. We brushed over them back in episode 2 when we covered variables and data types, but today it is a full-blown crash course. And trust me, by the end of this video, you'll see tables in Lua not just as collections, but as the heart of Lua's magic. So stick around, because once you really understand tables, everything else in Lua starts to click. Alright, let's dive in and unleash the power of tables in Lua. So, like always, first and foremost, let's talk about what are tables in Lua. If variables are like single pockets in your backpack, tables are the whole backpack. They can store numbers, strings, other tables, and even functions. So pretty much everything. A table in Lua is like a container where you can store multiple values. You can think of it as a list, as in like a shopping list, a dictionary, and also like a record where you can store player info in a game. And unlike arrays in other languages, Lua tables are flexible. They can act as both arrays, that is indexed lists, and key value pairs, that is dictionaries. So in order to understand them, let's start with a basic list of items stored in a table. We will now create a simple table which will be like an array or a list. So for that we have our compiler, where we'll type out a table variable called fruits equals a set of curly braces and then our items to store. So we'll store strings in this case. So this is apple, and then banana, and then cherry. Simple as that. So this is our table. And keep in mind that indexing starts in Lua from 1 and not 0. Yes, that is different from many other languages, so we can access these items using indexing. And if I wanted to access apple or print out apple, I would type out print fruits, a set of square brackets, and our indexing for our first item, which is 1. So this should give out apple. And this is clear from it. You can also add new elements at the end of the table using table.insert. So if I wanted to add a fruit named orange at the end of this fruits table, I would type table.insert the name of the table, that is fruits, and then the item you want to add. In our case, it's orange. Now this line essentially adds orange at the end of our fruits table, and we can check that by typing out print and then the fourth index of this table. So this should output to apple and then orange. And in order to remove this last item, we use table.remove. So table.remove and the table you want to remove an item from. So fruits. This removes orange. And now if we try to access the fourth index of our table fruits, let's see what will happen. So it gives us a nil value, and that is nothing, because nothing is present in the fourth index, since we removed orange, which was present in the fourth index. Now, what I just presented was about removing items from the end of the table, but if you want to remove an item from a specific index, you would have to do this. Well, suppose we want to remove banana, and remember that in Lua, the indexing starts from 1, so it is at the first and second index. First, then second index, we have banana. So in order to remove banana, I would have to print out table.remove the table name, that is fruits, and then our index. So as I said earlier, this will remove banana and cherry will take the place of index number 2. So let's run this code by trying to access our second index of fruits. So we'll have to type out print, then fruits, square bracket, and then the second index. So you can see that it gives out cherry that means banana, which was initially present at the second index, has been removed successfully. Now these were the cases where the table acts as a list, and as discussed before, tables don't just hold lists, they can also store named values like a dictionary. So let's see with an example about storing player info. Let me just remove all of this and then create a new table local called player equals, and write our keys, that is name, and then our values Alex, a comma to separate our keys and values, and then another key score. Let's say Alex has a score of 1200, and then let's say Alex is at level 5. So here name, score and level are keys, and the general format to store keys and values is keys equals values, and then a comma before the next key value pair. Keep the comma in mind or else it might throw an error, and we don't want that. So we access the values using our dot notation or square brackets, which I'll demonstrate right now. So print, if we want to access our player's name, let's say player name, and then concatenation operator, the name of our table, player dot, and then the key value we want to access. So since we want to access Alex, that is our name, I would have to write player dot name. And if we want to print out the score of the player, I would say player. In this case, I'll use our square brackets. So player, and then inside our square brackets, we have to use quotation marks to access the keys. So score. Now this will output to our score being printed, and this will output to our name being printed. So let's run and see. So player name Alex and score 1200. Now using dot notation or square brackets is totally your choice, and you can use either one to access our key value pairs. Now if you want to modify a value or add a new key pair value, we can achieve it by doing this. So player dot score will update our value by typing out player dot score plus 100. So this increases the score. Now if you want to add a new key value pair, let's say we want to add the number of lives this player has. So I would want to type out player dot our new key name, that is lives, equals 3. So this adds a new key pair value. Key value pair. Now we can access our score. So let's print out player.score and also print out our newly added key, that is player.lives. So we can observe that the score has been updated by this line right here, and we have added a new key value pair, that is lives. Okay, now that we have learned the basics of modifying tables in Lua, now let's have a look at how we can loop through them. You can loop through tables in Lua in two different ways. Since we have list style tables and dictionary style tables, there are two ways that you can use to loop for each of them. For list style tables, you can use something called Ipairs, and for dictionary style tables, you can use something called pairs. They are really similar to each other with some slight differences, and first we'll have a look at looping through list style tables, and that will be by using Ipairs. So let's get into coding. So I'll create a new table called colors, and I'll add some colors. Let's say red, then green, and then blue. So in order to loop through this table, we'll have to use this syntax: for index, comma value in Ipairs, then our table name, that is colors, do, and then our code to be executed for each item in our table. So print color and then index, and let's say it'll print out color 1 red, color 2 green, color 3 blue. So color, in order for it to print out 1, we'll have to concatenate its index and then our actual colors value. So semicolon and then value and then end. So hopefully it'll work as intended. So color 1 red, color 2 green, and color 3 blue. Now for key value tables we use pairs, and it is slightly different. So let's take our player table for example from before. So let me just Control Z all of this, and yeah, let's take this player table as an example. Now if you want to loop through this table, we'll have to use this syntax. For instead of index, we have keys in our table, so we'll write key and then value. For key value in pairs, clear, that is our table name, do, print key dot and our semicolon, colon, and then dot value, and then our end keyword. So this should give out name Alex, score 1200, and level 5. So this has worked as intended. So you might be wondering why we have to use Ipairs specifically for list-based tables and pairs for dictionary-based tables. So let's see if I use Ipairs, what will be the result. You can see that this doesn't output to anything. So in order to loop through dictionary-like tables, we have to use pairs. So hope that is clear. And one thing you might have noticed, you will see that pairs loops through all the key value pairs, but the order is not guaranteed. So in our table, originally name, score, level is the order, but here score is printed out first, then name, then level. So using pairs does not guarantee your order, but if we use Ipairs, it preserves the order. So that is why it is good for lists. Okay, now that we have learned about looping through our tables, we'll dive into the concept of nested tables, which will be our last topic for today's video. You can store a table inside another table, just like folders inside folders, and that is the whole concept of nested tables. Now I'll just remove this code and create a new table called game equals, and then it'll have a key called title equals, let's say, Super Lua World, and then stats equals another table in which a score will be our key, score equals 3000, then comma, make sure you don't miss your commas just like I did. So lives equals 3. Now in order to access our title, we can just type game dot title, and we have discussed this earlier. Now if you want to access our score key or its value, we will have to use two dot operators. So print game dot stats dot score. So that's how you can access our values that are nested inside two tables. This is useful for organizing complex data like a game character's inventory. And that was it about nested tables. Not only nested tables, Lua allows you to set something called metatables. Metatables are tables that can add behavior to other tables. And I know it might sound a bit confusing right now, but here's a fun example that will help clear all of your doubts. So what we'll do is we'll try to create a table and access a key that is not present inside the table. So we'll create a table called local car equals speed equals value, or let's say 60. So this has only one key. First, let's try to access that key. Print car.speed. So this will simply output to 60. Now what we'll do is we'll try to access a key called max speed. And what will happen is this will result in a nil value being printed out, since we have no key inside our car table called max speed. So let's run this and see. So 60 and nil. Now metatables can be a solution to handle this. We'll create a table. First we'll remove this, or let's say comment it out, and we'll create a table called metatable, which will hold a key called _index. It'll equal to a function which has table and key as its arguments or parameters. And let's say if key is equal to max speed, the key that we're trying to access, then it'll return a max speed of 200. So let's end this if statement and then end our function. And after defining our metatable, we have to write one more line, that is set metatable. First our initial table that we are trying to access the non-existent key, and then our actual metatable. So metatable. Now this line attaches the metatable to the car table, and from now on any operation on the car table that Lua can't resolve directly, like accessing a missing key, will be handled by the meta methods, that is in _index inside the metatable. Specifically, if you try to access a key that doesn't exist in car, Lua will first look for the key inside the car table, and if not found, it'll look for this _index variable inside the metatable. And if this variable is a function, as it is here, Lua will call it with car inside the table parameter and the missing key inside the key parameter. So you can think of _index as a fallback mechanism. Okay, now that we have created our metatable and connected it to our car table, let's try to perform our previous operations, that is trying to access this non-existent key. So I'll just cut this from here and print it out here. I'll remove the comment marks, and let's see what our operation or code will result to. So you can see that 60 is printed as it is, and this value, which was supposed to return nil, is returning 200 now, since we have this fallback mechanism that is our metatable. So that was it for today's video. And before we actually end the video, we do have a mini challenge for you guys. The challenge is to create an inventory system for a game that stores items, that is keys, item and quantity. And this can be achieved through what we discussed today. You can also add new items to the inventory and remove some when used. And a bonus task, you can print all of the items using a loop or a special function when you want to print all of the items. So this is the task to follow. And that's it for episode 6. Use the master tables, which are essential for structuring and storing data in Lua. From lists to inventories to game leaderboards, tables are everywhere. So if you like the video, don't forget to hit like, subscribe our channel for more such videos, and hit that bell so you don't miss the next episode. And until then, bye bye.